were heading into Rockland, you're cruising around here in Penobscot Bay, you're heading into Rockland, okay? And it's 13 nautical miles, all right, to Rockland, and you're making 9 knots. Okay, and you're, I don't know what, maybe, I don't know, maybe it's like 9 miles from Belfast to Rockland, okay? Anyway, you leave at 09:30. What time are you gonna arrive in Rockland? How are we gonna solve this? Okay, so first of all, we have to calculate our voyage time, right? Okay, so we're gonna calculate our voyage time, which is, okay, time equals distance over speed, right? Okay, you're not working again? There we go, okay? And, you know, if you use the 60D street, you know, time is D over S. S is D over T, or D is S times T. That's a beautiful little thing you can do. So then you gotta throw the 60 in there if you're trying to get minutes, okay? Anyway, cool, okay, great. So we gotta do that, all right? Now, here's a question. Are we gonna anchor along the way? Are we gonna stop and get fuel? In this situation, no. But if we were gonna do something like that, not only do we have to factor in how long it's gonna take us to go 13 miles at 9 knots, but did we stop anywhere? Okay? In this case, we didn't stop anywhere, we just went, okay? So, distance is 13, speed is 9, so that is 13 nautical miles divided by 9 nautical miles per hour. Nautical miles cancel out, and all you're left with now is hours. And, you know, the magic number there is going to be 1.444, okay? Okay, 1.444 hours. Okay, so Tyler M, I want to know what time I'm going to arrive by the clock. So I got 09:30. Okay, that's when I left. And now I got 1.444 hours. What am I going to do with that? Okay, well, first of all, I got 1 hour and then I got a piece of an hour, right? Okay, so I'm going to take the 1 over here and then I'm going to make the 4.4 times 60. Great. And when I do that, I get 27. So what am I going to do with that 27? Goes over here. And I get, 1027. Okay? Don't confuse the story with the facts. Okay, 1057. Okay, cool. All right, love it. All right, let's do another one. Same thing. This one's going to be just slightly longer. And, okay, so this one, it's legible. Okay, find the ETA. ETA to Boston, okay? The distance is 156 nautical miles. The speed is 12.5 knots, okay? We're gonna leave from, I don't know, maybe it's like 156 miles from here, okay? We're gonna leave here, we're gonna stop and we're gonna have a layover in Rockland. Of 2 hours. Okay, we're gonna buy some fuel there or something like that. I don't know. Go say hello to some friend on the dock or something like that. Okay. We depart at 14:30 on March 22nd. When are we gonna arrive? Okay. When are we going to arrive? How are we going to figure this one out? Same way, okay? We're going to calculate our voyage time. Our voyage time is going to be, well, okay, so voyage time. It's 156 miles divided by 12.5 nautical miles per hour. which ends up being 12.48 hours. 12.48 hours. Well, we can, but hold on a second. Okay, all right, so you can do that now, and then you can add 2 hours later, okay? Or we can add the 2 hours in now if we want, okay? So you can do either, all right? The way I'm gonna set it up today is we're gonna add the 2 hours in now, okay? So our voyage time involves time we're actually, okay, or, okay? Of course, if you're on a sailing vessel, it's gonna be more than 156 miles because you can't do a straight track, okay? Unless it was downwind the whole way. Anyway, so that was our underway time. Now I'm gonna go ahead and I'm gonna add my layover time. This was underway, this is layover. So I'm gonna get a total of 14.48 hours. 14.48 hours, okay? All right, sound reasonable? Okay, all right. Well, what am I gonna do with that? So what do I got? I've got 1430. So let's see, I got a March 03, 22, 1430. This is month. This is day. This is hour. This is minute. And I gotta have a column for each of those. I'm gonna break up the hours and the minutes, okay? So Tyler Hall, what time? I started on the 3rd month of the 22nd day, the 14th hour, the 30th minute. How much is my run time? What's my total voyage time? 14.48. 14.48. What if I get? What if this is ready to go into there? The 14's ready to go in. That goes here. What do I got to do with the 0.48? Times 60. Okay, and if you multiply that by 60, you should get 29. Where's that going to go? Okay, right here. What am I going to do now? Whoop. Okay. So what happens when I get 30 and 29? 59. How about 14 and 14? That's 28, isn't it? What's the day? It's the 22nd, 03. Anything wrong with that? Okay, there ain't no 28 days. So what are we gonna do with that? There ain't no 28 hours in a day. So what are we gonna do with this? Okay, so if I subtract 24 from this, I get 4. And what happens to the 24? So it becomes 03, 23, 04, 59. Okay? All right? So these are the kinds of problems we're going to be doing shortly. Okay? It's going to be, hey, you got this distance you're going to go. Except it's not going to be 156 miles. It's going to be 3,056 miles. So your run time is going to be like 10 days, 5 hours, 27 minutes. Or 9 days, 6 hours, 18 minutes. Something like that, okay? Your actual underway time. But then, okay, we're also going to say, oh, you're going to stop here to take on bunkers, and it's going to take 12 hours or 14 hours or 24 hours. That is going to have to be added to the voyage time. And then it might say, oh, you're going to go through the Panama Canal. Yeah, anybody been through the Panama Canal? Raise your hand. You're going to go through the Panama Canal. And you're going to give yourself X number of hours to transit the Panama Canal. You'll have to add that in. Or the Suez Canal or something like that, okay? Or the British Canal. All right? Right out here. Okay. So great. So everything we just did is going to be in that problem. But what do you think else is going to be in that problem if we're going like thousands of miles across the ocean? Okay, so date, time zones. We're also going to have to factor in time zones. Okay? So in this problem, we started in Penobscot Bay and we ended in Boston, both on the eastern seaboard of Los Estados Unidos. Okay? And as a result of that, they were in the same time zone. But in these problems that we're going to do, we're going to be dealing with different time zones. So we're going to review time zones here for a few minutes. You had this back in TNAV 1. Hopefully you've had it in CNAV. Have you guys had it in CNAV? Talk about time zones in CNAV? Yeah, baby. Oh, yeah. Okay. If I said table 36, do I get it? Oh, yeah. Well, I will in a few minutes. Okay. Oh. No, thank you. Actually, that's got. I'm gonna have to erase all that. I'm gonna erase all that. Okay. So now what we're gonna do is we're gonna go off the board for a few minutes, and we're gonna do a little bit of theory. Okay. Talk for a few minutes, and then we're gonna come back and do a calculation. So right? So right. All that crap we just did, by the way, is going to be in the PowerPoint if you want to download it. Those three, there were 3 problems, I only did 2 of them. Okay. All right, ready? Here we go. That is the Earth. That is the freaking prime meridian. What do you think? What do you? How are we looking at the Earth, Justin? Looking at that. What are we looking down on? What's right there in the center? You think? Yeah, well, that's the Arctic. Okay. Now it's no longer. You would think it was the Antarctic because there's actually ice there. Okay. In the Arctic now, there is no longer ice. So I can understand why you might have a misstep. But anyway, no, it's this. This is what we're looking at. Okay. So America, Europe, okay, Northern Hemisphere. And there is your prime meridian. And I just went like these. Doink. It's the polar view, people. Polar view. Cool. Ready? All right. Now, that is representing the prime meridian, Greenwich. So like there's London right there, Greenwich, okay? Now, cool, pole north. So there's the sun, do, here comes the sun. I say it's small, but it's really big. Anyway, this is not drawn to perspective, but from the distance that we are, the Earth appears to be about a quarter. If you took your arm, you went, the sun appears to be about a quarter's diameter, which is about 30 to 32 minutes of arc, depending on what time of year it is and where we are in our orbit, because sometimes we're closer, sometimes we're farther. That's why you got those 2 columns, that first page of the Nautical Almanac, and there's like the 2 columns for, right? Sometimes we're a little closer to the sun, and the sun appears bigger. Sometimes we're a little farther away from the sun, and the sun appears smaller. That's why there's 2 columns. Yeah, and there's about 2 minutes of arc. Why do we care about 2 minutes of arc? Because your sextant is calibrated to be accurate to a minute. So we should take in everything anyway, let's not worry about that. It's not CNAF. Ready? Do, 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 do. There we go. The Earth is spinning as the world turns. Sam Packett, yes. It took me an hour to make this goddamn simulation. You will look at it. Okay. So the Earth is spinning. Okay. The Earth is spinning. Now, we're using this longitude as our reference at the moment, okay? So here we go. It's coming around. It's coming around. It's coming around. Sunrise. Oh, I think sunrise just happened. What time is it right now? Noon. That's local apparent noon, by the way. Okay? Local apparent. What time is it now? 1800. Along that meridian. What time is it now? Midnight. Oh, maybe the next day. What time is it now? Oh, sun's rising. Okay, great. So that's what's going on. The Earth is doing that, right? Okay, great. Cool. That is, and then, so those are hours. Each one of those is an hour. There's like 6, 6 hours, 6 hours, 6 hours. And then those, I just didn't put the like 19, 20, 21, 22, 23, 20. Okay, got it? You guys like that? Okay, so that's called solar time, people. It's called solar time. And that is the time that everybody kept until we had the telegraph. Okay, and the trains. Okay, Everybody kept solar time. You kept, somebody was watching when the sun was as high as it was, wherever you were on the earth, somebody would ring a bell and everybody knew it was noon. Okay? Yeah. But your noon was different from somebody else's noon because they were east or west of you. But it didn't matter because we couldn't pick up the phone and call your buddy in the middle of the night until we had the telegraph. So they run this telegraph thousands of miles and somebody's going, and I was like, what the hell, dude? I'm in bed. Okay. Oh, sorry, I didn't realize. Okay, because of long distance communication, suddenly, all right. So anyway, so we went from solar time. First of all, there's solar time. How long is a day? Oh, it's 24 hours. Bullshit. There's only like 4 days in the entire year that are actually exactly 24 hours long. Most of them are a little bit longer or a little bit shorter. So the 24-hour day is a mean solar day. It's the average of all the solar days in the year. I'm not going to dive too much into that. Okay, so here we go. Now, this is Greenwich. Greenwich. Justin, what time is it in Greenwich right now? See that line goes right down there? What time is that? Yeah. Oh, hey, buddy. Oh, hey. Okay, now look. This is some place. This is some meridian in the Eastern Hemisphere. You see, that's Asia right there, okay? A little Russia, a little bit of China, okay? Right there. We're looking at this now, okay? Chuck, what's the time difference between Greenwich and this place right now? 6 hours. Yeah. So if it's 1800 in Greenwich, what time is it along that meridian? Okay, now are they ahead or are they behind? They're ahead. How many hours are they ahead? Oh, yeah, they're freaking 6 hours ahead. Anybody on that meridian is 6 hours ahead. What time is it in Greenwich? What time is it in wherever that is? You ready? What time is it in Greenwich? Midnight. What time is it along that meridian? What's the time difference? Wasn't it 6 hours before? Oh shit, it's still 6 hours. Oh. What time is it in Greenwich? 5 o'clock in the morning. What time is it along that meridian? Now don't worry about the lines are misaligned, okay? Okay, all right, the lines are a little bit screwed up. Okay, pay no attention to that man behind the curtain. I am the great and powerful Oz. Still 6 hours. It's always 6 hours. Okay, this is where our time zones come in. Okay, we use Greenwich as our reference. We use Greenwich as our reference. It is 0. It is 0. And then everybody else is some number of hours ahead of or behind of Greenwich. And it's fixed. It's always that way. Sorry, Charlie. Okay? I don't even know where Charlie is. He's not here, but anyway, sorry to him. Okay? All right? So, we're going to name these time zones. What is the value of this purple time zone relative to Greenwich? What is the value in hours? If we're going to, it's 6, okay? So we're in the Eastern Hemisphere. Okay, this particular guy is 6 hours. It's 6 hours. It's ahead of Greenwich. If I wanted to determine, if I wanted to take my local time and convert it to what time it is in Greenwich, how would I apply this 6 hours? Okay, I subtract. To go from local time to Greenwich time, in Eastern Hemisphere, what do I do with the time difference? I subtract it. So all of our Eastern places are going to be given a minus sign. All of our Eastern places are going to be given a minus sign because we're going to do math with that freaking number. And to go from local to GMT, you will subtract East time zone. Okay? So we're going to call that time zone -6. Okay? We're going to call that time zone -6. Let's see here. Patrick, what if there was this, what about this time zone halfway between those two? What are we going to call that time zone? This one is -6, that's 0. What do you think halfway between it's going to be? -3. -3. Why do I call it -3? What if it is, so what time is it? In this particular, if I had a time zone right here, I was on this right here, what time would that be exactly, Patrick? 8 a.m. And how would I get, what would I have to do with that 3 hours to get to Greenwich? And what is 8 minus 3? 5. What time is it in Greenwich? Oh, shit, it works. Cool. All right. But what if I was in, this is Greenwich. What if I was here? This is, so here is the Eastern Hemisphere, here's the Western Hemisphere. Okay, so I go over here. That's 6 hours difference. Okay, west. It is also 6. This particular longitude is also 6 hours. What do I have to do to this 6 hours, though, to get to Greenwich? Oh, I got to add it. Oh, west. When we name our time zones, we have a convention. And the convention is to name them by the hours difference. And then the sign will be given what you will do to convert it from local to Greenwich. Okay? Dylan. What's this time zone? Well, it's -6. 1, 2, 3, 4, 5, 6. It's -6. Okay? If it's 11 o'clock, now it's 11 o'clock in there. It's 5 o'clock there. That's 6 hours difference. Okay. What's the time zone called? -6. It's 6 hours. It's -6. Okay? Why did I call it -6? Yes. Okay, now, here's the flip side of it. It is now, what time is it in Greenwich right now? It's 5. What's this time zone called? -6. Okay, there's a difference between time and time zone. Okay, there's a difference between time and time zone. What's this time zone? -6. What's this time zone? 0. What time is it in 0 right now? What time is it in -6 right now? Oh, shit, yeah. Okay, now, to go from local to Greenwich, what did we do with the Eastern 6? We subtracted it. To go from local to Greenwich in the west, what did we do with the 6? We added it. Okay? We added it. This is how we name our this is how we name our zones, okay? So, anyway, standard time, blah da 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 da. We have to subtract 6 to get to GMT. Okay? Olivia though. What if I told you, wait a second, we're going like this. Oh shit. Okay, Olivia, what time is it in Greenwich? Yeah, it's 9 p.m. It's 9 p.m. Olivia, what is this zone description? Oh, it's -6. It's east, so we call it -6. But, okay, it's east, it's -6. Because it's 6 hours, you have to subtract 6. You have to subtract 6 to go from here to there. But if I told you, Olivia, it is now 9 p.m. in Greenwich, what time is it in the -6 longitude, time zone? what would you do to that -6? What time is it here? It's 9 p.m. It's 9 p.m. What's the name of this time zone, Olivia?
-6.
What are you going to do with that 6 now? Are you going to subtract it from 9? Oh, what did you do to the sign of the zone? You flipped it. You flipped it. Okay? In this nomenclature that we're going to do, we're going to name Eastern longitude is minus. Okay? Eastern longitude is minus. Western longitude is what? Is plus. It's minus. When do we follow those rules? Oscar, when do we follow the rules where we actually minus if it's east and we plus if it's west? When do we follow those rules? When we're going from local, we follow those rules when we're going from local to GMT. Oscar, when do we follow the frickin' rule? We call that one -6. When do we follow the rule that we actually subtract 6? When we go from local to GMT. What time is it right now in this time zone, Oscar? 3. So it's -6. What time should it be in Greenwich? 3 o'clock in the morning. Take away 3, push you to midnight. Another 3 puts you to 9 p.m. Look, 9 p.m. But Oscar, you subtracted the 6 going from here to there. But it's 9 p.m. It dropped again. It's 9 p.m. in Greenwich. What's the hour difference between Greenwich and this time zone?
6.
Are you going to subtract that 6? Why did you add it? Ah, yes. From local to GMT, respect the sign. GMT to local, what do you do when you're going GMT to local? You flip the sign. Okay? Woo! Okay? This is important. Samuel! I need a better clicker. Okay, so there's 24 time zones, okay? There's 24 time zones. These are all east. What sign will they, when we name them, what will their sign be? These are all west. When we name them, what will their sign be? Positive. What will the number go up to and then stop? 12. So this is -12. This is +12. Okay? 12 and 12 is? 24. Beauty-muss. Okay, great. All right, so here's time zones. Okay, now, these are all east. These are all east, right? So if this is 3 hours difference, what should this time zone be called? -3. What's it called? Well, shit. Okay, now I just want you to realize something. We use a system where we name them going from local to GMT, but not everybody in the world does it. Some systems use GMT to local, okay? So I just want you to be aware of that, okay? Yeah, exactly, okay? Anyway, so our time zones, by the way, are 15 degrees of longitude long. This is where we standardize the time. Everybody keeps the same hour, okay? And so there's the prime meridian, 0, and 7.5 to one side, 7.5 to the other, that's the 0 time zone. And then 15, that's the center of time zone -1 if it's west. And so that goes from 7.5 to 22.5, yada, yada, yada. You know all this from CNAV, okay? Okay, great. So this is a summary slide. We've pretty much said all this already. Okay, all right, so. Sam. Andrew. 163, 14.7 east. we're gonna name this. First of all, what sign is it gonna get? Okay, it's 163, 3, 14.7 east. What is the sign going to be of the name of this time zone? Okay, so it's east, 163, 14.7 east. Right off the bat, it's going to be minus. Now, how are we going to figure out what it is? Which number? Okay, so you're going to convert this 14.7 minutes. You're going to divide that by 60, and you're going to add that to 163. That's essentially what you have to do. And when you do that, you're going to get 10.88. Now, we don't want the decimals. We're going to use the rules of rounding. So 10.88, what does that get rounded to? Well, we're going to round it to a whole number. 11. Okay? So it's 11, and it's east, it's minus. 163, 14.7 east is 11 minus. Okay? All right? Yeah, that was fun, wasn't it? Yeah? Huh? Damn you! Okay. Sam, welcome back. Thanks for volunteering. Sam, 5731.1. Okay, 5731.1 west. Okay, Sam, you put your freaking calculator down. Sam, what's the sign going to be for this? Plus or minus? Plus. Okay, it's going to be plus. We know that's going to be plus. Okay, now, how would you do it mathematically?
I would convert the 31.
Divide that by 60, add those two together. And when you do that, you'll get 3.83. What are you going to do with that? You got to round it to a whole number. Up or down? What are you going to round it to? 4. And it's west? Okay. Olivia. If I told you it was 0900 at 57:31, what time is it in Greenwich? What's that? It's 1 o'clock, 1300. Great. Because when going from local to Greenwich, I respect the sign. But what if I told you it was 6 p.m. It's 1800 in Greenwich. It's 1800 in Greenwich. What time is it? What time is it at 57 West? Oh, you're going to subtract. When going from Greenwich to local, you're going to flip the sign. You're going to subtract. Yeah. Okay, cool. All right, so anyway, there's another example of that, blah, blah, blah. But check this out. You ready for this, people? You ready for this? Are you ready? Can you handle this? Can you handle the truth? Have you seen this table? No? Have you seen this table? Okay, in your Bowditch, you have 3 different Bowditches, perhaps all digital. Bowditch 2, 1981, it's called Table 36. Bowditch 2, 1981, it's called Table 36. It's on page 370. This is the Bowditch 2, 1981, is the Bowditch you're going to have on the Coast Guard exam. It's the Bowditch you're going to have on all of your ANAV exams next semester. It's the Bowditch you need a physical copy of. Okay? So, 163, 14.7. Chuck, it's east. Let's look at this table. What do you notice about all the signs on this side of the table, Chuck? What about this side of the table? So if I get 163, 14.7 east, am I going to go to this side or the right side or the left side? Oh, hell yeah. Now what do I got? Oh, 7.5 to 7.5. What time zone is that? West to east? Oh, God, that's time zone 0. And then, east, they're all minus. Oh, that makes sense because east are all minus. And this is time zone 1. It goes from 7.5 east to 22.5 east. What's dead center in the middle of that? 15 east. Right in the middle of all these is your central meridians, multiples of 15. 15 is in the middle of that. 30, 45, 60, 75, 90, so on and so forth. Shit. Check. 163, 14.7. What freaking time zone is it in? You tell me when to stop. Right there. Chuck, what is that time zone? Didn't we just do that by like doing like divide by 60, add it, then and multiply? Yeah, we can do it by the freaking table. Dylan, 5731 west, left side, right side, left side, right side, right side. Okay, you tell me when to stop. What is it? +4. Shit. What are you going to do with that +4, Dylan? You're going from local time. You're going from local time to Greenwich. What are you going to do with the +4? You're going to keep it. You're going to respect the sign. Dylan, you're going from Greenwich time to local. What are you going to do with that? You're going to flip that shit. Okay? That's what we're going to need to do for these problems. All right? And we're going to launch into some problems here. Oh, by the way, let me just tell you a little something. Okay? Let me just tell you a little something. Oh God, questions? Can't you guys just keep your questions to yourselves? Am I getting paid to answer your questions? Oh yeah, I am. Okay, yeah, what is it?
What did they skip J?
J is in the letters of J is like number 13. Okay, it's very, I don't know. Did they skip J?
Yeah.
I never noticed that. I think that whoever made this system up had just had a really bad breakup with somebody whose name began with J, and they're like, screw it. I mean, that's somehow, I don't know. I have no idea.
We should go back and rewrite
Anyway, I don't know why.
that. Inclusive of Juliet.
Look, Justin, oh, see, Justin didn't like me talking about J, so he's walking out of the room. Okay, so, look, the 15-degree rule divided by 15 is an idealized thing based on the Earth's rotation, but countries don't respect it. This is the international date line. Look at this. So this is 7 a.m. These guys over here are keeping 7 a.m., whereas these guys down here are keeping, in Fairbanks, they're keeping 9 a.m. In the same longitude, these guys in Kiribati, Christmas Island, are keeping 7 a.m. That seems crazy, doesn't it? You know why that is? Kiribati is a string of islands, Kiribati, okay? The nation of Kiribati, okay? Christmas Island being there. And they've decided they want all the islands to be on the same time. So they're not respecting this 15 degrees of longitude, hour thing. Time zones are actually determined by politics, okay? So if you are going from one place to another and you think, oh, it's X number of degrees of longitude to that place, I should divide by 15 and I'll get the time zone they're keeping. You could be for a rude awakening because they may not be respecting that. On top of that, it could be daylight savings time. So how are you going to know what time a particular place is going to be keeping at any particular time of the year? Well, yeah, you're going to have a book on the vessel, or you'll have the internet available to you these days. Well, anyway, and you're going to look up the zone description they're keeping at that particular time of the year. And that's the zone description you're going to use to figure out what local time is, okay? You can't always rely on dividing it by 15, okay? Because half the time in the United States, when we're in daylight savings time, we're not keeping our time zone, okay? We're not keeping our time zone right now. Our time zone is +5. Excuse me, our time zone is -5, but we're keeping -4 right now for political reasons, okay? All right, let's take 5 and we're going to come back and do a calculation. Here we go. Everybody, pull up your handouts. Pull up your handouts, page 1. Your handout's right behind you. Okay, pull up page 1 of your handout. Okay? Patrick, page 1 of your handout. Okay, so this is what we're going to do here. Okay? This is how I'm going to suggest we do this problem. We're going to read the problem. And the first thing we're going to do is we're going to calculate the voyage time. Okay? Calculate the voyage time. Just like we did before. What do we do? Oh, we're making, we got to go 150 miles at 14 knots. Okay? So that's going to involve the steaming time. Okay? the bunkering time, because, you know, we stopped in Rockland to take for 2 hours, right? And maybe some kind of transit time. And we're going to add all those up, okay? We're going to do this first, and we're going to leave it aside, and we're going to come back and pick it up, okay? And then what we're going to do is we're going to set up a table, a computer, as it were. Okay, we're going to set up a table. We're going to set up a computer. Actually, I'm going to change the numbering on this thing. So it's numbered up like this, but I just decided I'm going to change it. It's a two-step problem. First, we're going to calculate the voyage. We got to do all this. Okay, and then we're going to do our table computer. Okay, and our table computer is going to be, here's how it's going to go. You're going to go month, day, hour, minute, just like we did before. Okay, just like we did before. All right, now, the only difference is, when we started this table before, Oscar, what did we populate in this? Remember, this was going from like here down to Boston. It was March 3rd at da-da-da-da-da. Okay, so the first thing we're gonna do is we're gonna populate this table, the month, day, hour, and minute of our departure. So we're gonna call that zone time of departure. Okay, the top of the table, we're gonna put in the zone time of our departure. Okay, now what's the next thing we're gonna do? Then we're gonna apply our zone description. Okay, why? Because we're gonna go from zone time to what? We're gonna go, if we apply our zone description plus minus to our zone time, what time do we get? GMT. What am I going to do with the sign? Tyler M. If I'm going from zone time to GMT, my time zone has a sign. What am I going to do with that sign? Am I going to respect that sign or am I going to flip it? Oh, I'm going from zone time to GMT. I'm going to keep my time zone. Okay, so the zone description of departure. And you keep it. Keep sign. Now I get my GMT. What am I going to do now? I'm going to add in my voyage time. Month, day, hour, okay? What am I going to do then? I'm going to add it all up. And what will I get? If I take my zone time, Rebecca, I apply my zone description, I get GMT. That is this is GMT of departure. It's departure time, but not in local time, in GMT time. Now I add like a bunch of days while I'm going brum, 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 or what do I get here? Oh, I get what kind of, it's arrival. Oh, it's GMT of arrival time. It's GMT of arrival time. Cool, cool. Tyler, H, thanks for volunteering.
You're welcome.
Do I want to leave, if I'm arriving in a country, do you want to have your ship in frickin' GMT time? What do you want to do? Oh, you want it to be in local time. Zone time of arrival. Tyler Hall, how am I going to go from GMT to zone time of arrival? What do I have to apply? Oh, I got to do my zone description of arrival, but you absolutely are right. I have to flip the sign. Okay? That's what I got to do. Ready? Yeah? So now we're going to do that. Okay, and this is just the table. Okay, this is the table and the PowerPoint. Okay, this table is going to stay up here. Let's do a problem.
You said the first M was minutes.
Month, day, hours, minutes. Okay? All right, now we're gonna do problem one. Problem one. Patrick. To do problem one, what I wanna do over here is on this side, I'm gonna do step one, voyage time. Okay? And then over here, I'm gonna do my voyage time is gonna be over here, and then over here is gonna be my computer. Patrick, help me set up my computer. I'm gonna reproduce that. So I want what? Month, day, hour, minute. What do I want here? First line. Zone time of departure. So I'm gonna abbreviate it now. I'm not gonna write out all those freaking words. Zone time departure, okay? Oscar, what's the next thing I'm gonna do? I wanna convert my zone time of departure to what? Okay, so I'm gonna do my zone description, okay, for departure. Am I gonna keep that sign or am I gonna flip that sign? You're gonna keep that shit. Yeah, exactly. Great. And that gives me GMT of departure. Okay? GMT of departure. Olivia, I have my zone time of departure. I apply my zone description for my departure time zone. I got GMT. What am I gonna add in next? Oh, and I'm gonna add my voyage time. Oh, it's the voyage time that I calculated over here. It goes right here. Okay? I'm just gonna call it voyage. Or you can just say V. Okay? I'm gonna add those up. Okay, I'm gonna add those up. Justin, when I add my voyage time to my GMT departure time, what am I gonna get? I'm gonna get the GMT of where? Where am I gonna be at that point? Where on the earth am I gonna be? My destination. So I'm gonna say GMT of arrival. Okay, let's go GMT of my arrival. Okay, I'm just writing this whole, we wrote the table, we're writing it again. You should write this table every time you do one of these problems so that you have it drilled into your head. Chuck, do I want GMT time of arrival?
Yes.
What, am I gonna leave my clock in GMT?
No.
What am I gonna do?
Oh, sorry. Yeah, you're gonna take your ZD and your zone description.
ZD of arrival.
And your zone time.
And I'm gonna get my zone time of arrival. What am I gonna do with that ZD of arrival? I'm going from Greenwich to local. Am I gonna respect that sign? I'm gonna flip it. Okay? All right? So we just wrote the table twice. The second time I just abbreviated it a little bit. I do this every time I do one of these problems. I suggest you do as well. All right. Now we're gonna start the calculations. Now we start the calculations. Okay, so let's read the thing. Let's read the problem, and as we read the problem, we're gonna populate. Okay, so Dylan, you start reading the problem, all right? Okay, stop right there. 0915, where's that gonna go? Is that gonna go here or over here? Dylan, where's it gonna go? Where's the 09 and the 15 go? Yep, 0915, awesome. Okay, Rebecca, you pick up the next 09 zone time on, where's that go? So 6. Now, do you want to put MAR here, or we're gonna maybe have to do some math on this. So let's put 03. Okay, cool. That we're gonna do math on it in a little bit, maybe. Okay, all right, cool. You depart Sydney. And they give us our longitude, okay? 151, 15.3 east. Oh, what's this? Olivia. So we depart on March 6th. So you read the next bit. Oh, what's the bit that we like there? Where does that go? Yes, that's going to go here. That's the zone description. Okay. Now, if they didn't give you the -10, Olivia, what would you have had to have done? Well, you could have done the math, or you could have gone to table 36. Okay. Okay, great. But if they give you a zone description, you better use it, because it could be that that's actually, like, by the math, it's 11, but they're in daylight savings time, so they're keeping 10. So if they give you the freaking number, use the number. Do not do the math. If you do the math, the number might be right, the math might be right, might be wrong. And if they give you the number, it saves you the work of doing the freaking math. If they give you the number, use the freaking number. Okay, you're bound for Kodiak. Oh, great. What's the longitude of Kodiak? What's the zone description? They didn't give it. So what are we going to have to do? Okay, now if they didn't give you the zone description, then you can rely that the table will give you the proper zone description. You see how it works? No, they're not. Okay? If they give you a zone description, use it. If they don't, you can trust the zone description that you'll get by math or table 36. What's that? What's that? I guess what I'm trying to tell you is that if the place is not keeping the mathematical zone description, they're going to give you the zone description. Yeah. Okay. It might. Yeah, it might. I don't know. I don't think you're going to see any of those problems, but next year in ANAV we will, and we'll deal with that then. Okay, great. So, all right, now, who's the next victim? Volunteer here. So, Oscar, now we're talking about the voyage. Tell me about the voyage. Okay, so what am I going to do? I got 6,222 miles. I got 21 knots. What am I going to do with those things, Oscar? Yes, so I'm going to go like this. Okay, so that, if I did that math, that's going to be 12.35. Okay, now look, this is nautical miles. This is nautical miles. This is important. This is nautical miles. What's speed? Nautical miles per hour. What happens? The nautical miles cancel out, and I got 1 over 1 over hours, which ends up flipping over, which means this is hours. Excuse me. Wait a minute. Wait a minute. Yes. I skipped a step. I skipped a step. Yeah, it's 296.29. I went to the next step. This is nautical miles. This is nautical miles per hour, which means this is 296.29 hours. Yeah, thank you. Okay, it's 296.29 hours. Okay, this is what's going to happen. Because distance divided by speed will always give you hours if your speed is in knots. And our speed is always in knots, which is nautical miles per hour. So this is hours. I need to break it up, though, into month, day, hour, minute. How am I going to take 296 hours and break that up into? Okay, but yeah, but I guess I'm going to have to do some funkiness. I'm going to have to do some division, right? Okay, so, but before I do that, though, I'm going to stop for a moment. I'm going to say, do I have any layover time? Do I have any bunkering time? Do I have any transit time? If I did, in these problems, they give it to you in hours. If I did, I would add those in right now. Okay, but there's not. So what am I going to do with this 296.29? 296.29 hours. What am I going to multiply? I'm going to multiply that by a conversion factor. I need to convert that to days. So how am I going to get rid of hours and make days show up? Times 1 day for every 24 hours. See? So I'm going to divide that by 24. Okay? I'm using conversion factors. I have hours, I want days. 1 day is 24 hours. If hours is in the top, I'm trying to get rid of it. I got to put hours in the bottom to get rid of it. So when I do that, now I get 12.35 days. I get 12.35 days.
Yeah.
Okay, 12.35 days. Okay, and then we're going to times, so the 12 comes out, and then we're going to times this by 24. So that gives us what, 8? 8.29. Okay, 8.29. That's hours. Okay, there we go. Now we're back on track. 8.29 hours. So the 8 goes here. Now the 0.29 hours, what do we do with that? Okay, so the 0.2 hours, I have to multiply times 60 for the minutes. And now I get, that's the last bit, 17. Okay, now we're back on track. Sorry about that. Can't read my own notes. Okay. So the voyage is 12 days, 8 hours, and 17 minutes. Okay? So, Sam. Oh, I didn't do this part. So let's start doing some stuff here. What do I got? What happens here?
You go down a day, so it'd be March.
Yeah, so I got to go like this, 05, and how many hours am I going to add here?
You're gonna put 23 there.
So 24 and 9 is going to be 30, 24, 30, 33. So what's 33 minus 10? 13, right? Is that right? God, did I make another math mistake? 23, okay? 23. 05, 03, 15. Our voyage time is now 12, 8, 17. So what are we gonna do with all that? Gotta add these two. What do you get? 32. What happens when we add these two? You get 31. What happens when we add these two? You get 17. What happens when we have this? This is still 3. Okay? Now, what should we do now? What do you think about this? What do you think about this 31? Okay, so I'm gonna just, yes, we could subtract 24 from this now, because there's not 31 hours in a day. This would go to 18 and this would go to 7. Okay? But I'm gonna tell you that if we do that now, when we get to this step here, we're gonna have to borrow. So I would suggest that we just leave it funky now and at the very end, we fix it all. There isn't 31 hours in a day, but I'll just show you what's gonna happen here. Okay, so if I subtract 24 from here, that becomes 7, and this becomes 18, okay? This becomes 18, all right? But what's gonna happen here in just a minute, when I put my zone description in here, it's gonna be bigger than the 7. So I'm gonna have to actually flip it all back to 31, okay? So let's just look at this for a second. I can do the math on that 152.25, or where can I go? There's the math, plus 10. You see how we're gonna have a problem here in a second? Okay, so I'm gonna go to my table and Tyler M. What's am I west or east? 152.25 west. Okay, so you had 50-50. Baby did not get the shoes. Baby, you'll get the shoes now. What's my time zone? 152 west based on this table. What's my time zone? Plus 10. Okay, so where's that plus 10 gonna go? Plus 10. Oscar, am I gonna add that 10? I'm gonna subtract it. Now, Oscar, did you subtract 24 from 31 to get 7 and make that 18?
Subtract 24 from 31.
Well, yeah, so, Well, but see, now I have to reverse the sign, right? So now I got to freaking borrow it back. So this is what I'm trying to tell you here. When you get to this step, resist the urge to convert until after this step. Because now I say, oh, 31, there's not 31 hours. So I subtracted 24 and I made that 17 to 18. But now I got to borrow it back because 10 is bigger than 7. So don't do it at this point. Do it down here. So I'm going to leave this as 31, 17. What happens now? What's my last line? What's this going to be? 32. What's 10 from 31? 21. What's 17? 03. This is my arrival. Okay? Nope. Using this system, you never have to even consider the date line. This is the beauty of this system, okay? What day did I leave? But I've put it into GMT. I arrived in GMT. This takes care of everything, including if there's a date change, it'll take care of the date change as well. You don't have to think about it at all, Chuck. That's the beauty of it. If you follow this system, you'll never go wrong, okay? If I had not put it into GMT, so Chuck, if I hadn't done GMT here, but I had done all that stuff, then I'd have to start thinking about that stuff. I'd drive myself crazy. Don't do it that way, okay? If you cross the date line, it's all taken care of by the computer. All right? Okay, let's do another one. We're gonna use the same computer, okay? But now we're gonna jump to, go to page 5, problem 1. Page 5, problem 1. ETA with port time. That whole problem, by the way, is in the PowerPoint, okay? Okay, this is the one we're doing now. All right, so we're gonna do voyage time over here. I want this one. Can you guys see that V, or is that too dark? Okay. Yeah, okay. Okay, we're gonna do voyage time over here. We're gonna do our computer over here. Okay, so my computer is gonna be month, day, hour, minute, zone time, departure, zone description of departure, GMT, departure, voyage, GMT, arrival, zone description, arrival, zone time, arrival, flip, keep. Okay? I'm all ready to do the problem now. Okay, I'm all ready to do the problem now. Okay, so last time when we did it, we pulled every bit of information out and we populated it as we were reading. This time I'm gonna do it slightly differently. What I'm gonna do is I'm gonna zero in on the voyage first. After I've done the voyage, then I'm gonna populate the table. And then you'll get to decide which way you wanna do it. This time we're gonna do the voyage, all the voyage stuff first. After the voyage stuff is done, we're gonna read the problem again and then we're gonna populate the table. So let's just read the problem and figure out what is the voyage information that's important. Rebecca, what is the only information we need about the voyage right now? I want the distance, I want the speed, I want the layover if there is one, and I want the transit. So let's populate this. Go. 3180. What's the speed? 14. Okay, nautical miles, knots. What is the, is there a layover? 24 hours. Okay, so there's a 24-hour layover for bunker, okay? And there's a 12-hour transit. Okay, that's all the stuff I need for my voyage plan. Okay? All right. So let's attack the first thing first. Let's do the underway time. What is our voyage? Voyage is underway, layover, and transit. We need the underway time, distance and speed, the layover as given, the transit as given. You ready? Here we go. What is our underway time? I've got 3150 nautical miles divided by 14 nautical miles per hour. Okay, Olivia, when I take 3150 and divided by 3150 nautical miles divided by 14 nautical miles per hour, bless you. And God bless that wet mask that you're wearing now. What units am I going to end up with? Nautical miles, what happens to nautical miles? They cancel out, and this is 1 over hour. It's going to end up being hours. So what is 3150 divided by 14? 225. So that's 225 hours. Okay? All right? Cool. Now, Tyler M. 225 hours. 225 hours. What do I want to convert that into? Days, and then hours, and then minutes. Okay, great. So how am I going to take, I got 225 hours. How am I going to convert that into days? What am I going to multiply that by? How many days are there? How many hours? What's the relationship between days and hours? Okay, so I'm going to multiply by something. Okay, yeah, because you see, hours. I got to put the hours at the bottom till they cancel out. So that the 24 has to go down there, and 1 day goes up here. Good. So what is 225 divided by 24? I'll tell you. Oh, wait a second. Wait, hold on a second. Hold on just 1 second. Hold on just 1 second. Just 1 second. 1 second. What is this? It's hours, right? What's this? What's this? What do you think I should do right now? I'm going to combine all the hours. What I'm going to do now is I'm going to combine 225 hours underway plus 24 hours bunker plus 12 hours transit. So 225 plus 24 plus 12, what's that? 261 hours, okay? I'm going to combine them all right now. 261 hours. All right. So I've got 261 hours. That's my total voyage time in hours. So Chuck, what am I going to do with that now? What do I want to convert 261 hours into? Okay, so I got to go to days first. So what's the relationship between hours and days? 1 day for every 24 hours. So hours goes away. What's 261 divided by 24? 10.875. That's days. Chuck, what am I going to do with that 10.875? Is there any useful information from that?
Yeah, 10 days.
Okay, the 10, I can strip the 10 off. Where does that go?
Day, the voyage day.
10. Okay, great. Okay, 0.875 days. 0.875 days. What am I going to do with that? Okay, well, now I got to convert days to hours. Okay? So what do I want? I got 0.875 days. I want days to go away and hours to show up. So I'm going to multiply by a conversion factor. If days is what I want to disappear, where does days have to go? In the top or the bottom? Bottom, days. How many days? One for how many what? 24 hours? Oh, there we go. Days goes away. What's 0.875 times 24? 21. Is there any decimal there? So we're done. Okay, that's the total voyage time. Okay. Okay. So Sam, what's the first line? What are we going to populate the first line with data? What's the data for the first line? What's going to go here?
Let's see, you're gonna do January
01.
28 for your day.
28?
You have departure time is 18 hours, 36 minutes.
1836. What's the next bit of information I need?
Your zone description plus 6.
Okay, zone description for departure or arrival? What do I need next? Arrival or departure?
That's departure.
Departure. Okay, so it's +6. Where am I going to put that?
You're gonna put that below the 18 for hours.
Yeah, okay. Am I going to respect that sign or am I going to flip it? Okay, great. Cool. So Justin, what's the next step?
I don't know, sorry.
We're here.
Okay,
36.
Yep.
What's 18 and 6? 24. What's this? 28. 01. Okay, now, if you want, you can convert this right now, or you can let it ride until the end. Since this is going to be a big number when I add them, I think I'm going to convert it right now. What does 24 become? It becomes 0. And what does 28 become? It becomes 29. Okay? So actually, let me write it this way: 29 and 0. Okay? So Olivia, what's my zone time of arrival? My GMT of arrival. What am I going to do with all these numbers? 36. What's 21 and 0? 21. What's 10 and 29? 39. And what's 01? 01. Oh, crap. It's January 39th at 21:36. What's the problem there? Okay, how many days does January have in it? How many days does March have in it? How many days does August have in it? Show me the power, people. Show me the power. Your knuckles. Put your hand up. Put your hand up. You got knuckle, valley, knuckle, valley, knuckle, valley, knuckle. Then you got another hand. So it goes knuckle, valley, knuckle, valley, knuckle, valley, knuckle. Then you go to the other hand, knuckle. So January, 31. February, less than 28 or 30. March, 31. April, 30. May, 31. June, 30. July, 31. I go to my second hand, August, 31. Or I can just go July, August, and then start working my way back. So I go January. Oh, January is 31. So minus 31. What do I get when I subtract 31 from there? 08. What happens to this? It's February 8th at 21:36. Okay? What's my zone description of arrival, Oscar? +8. Okay, so that was +6 for that one. This is +8 for that one. Anything I want to do to that? Flip that shit. Okay, what's my final answer, Oscar?
02, 08, 13, 36.
That's it. Done. Okay? And that's it. We're done for today. Is that danger zone?
Yeah.
Okay. All right. So that's how those problems go.